How's it going, everybody? My name's Kaz and welcome back to the channel. Today I'm going to show you how to code a fully external ESP for CSGO using an overlay. And I know that sounds pretty hectic, so let me actually show you what we'll be making today. I'm currently in a CSGO bot match, and when I run the program, as you can see, the enemy positions are revealed to me through the walls. It's an extremely simple ESP, but that's not the point of this video. The point of this video is specifically to show you how to make the overlay, because these days with modern anti-cheats like EAC or BattlEye, you have no chance of going internal, and therefore kernel drivers and overlays are the only way to go. After completing this tutorial, you will have an overlay that can render over pretty much any game of your choosing, and if you mix that with a kernel driver, you can start selling your awesome pay-to-cheat tomorrow. So let's do it. Just before we jump in though, if you do enjoy the video, it would mean the world to me if you consider dropping a like or subscribing. If you're looking for the source code to this video and many others, you can find that on my Patreon down below. And last but not least, if you run into a problem and need some help, feel free to join my Discord server and come chat with us. Anyway, ladies and gents, let's jump into it. Alright, ladies and gentlemen, I don't know if you expected this, but we're going to start the tutorial by creating a new project. I'm using Visual Studio 2022, as you may or may not be able to tell. We're going to go ahead and click create a new project. Now, I like to use empty projects because that gives you the most flexibility as to what you might want to create. Now, obviously, empty project is under recent project templates for me because I use it all the time. If you have never used it before, you're going to have to come to the search bar and you're just going to type in, empty. And once you have empty project, you're going to click on it and you're going to click next. Now, I'm going to save this project to my desktop and I'm going to call it Sexy ESP because I'm an extremely creative individual, actually unmatched. Anyway, create. Now, once you have created your project, the first thing we're going to do is we're going to come to this button, which says show all files, and we're going to click that button. That removes the whole Visual Studio filter bullshit. We don't care about that. Next, we're going to come over here and we're going to add a new folder and we're going to call it SRC. SRC means source, and that's where your source code is going to go. So we're going to start by creating a new item, and that new item is just going to be a C++ file, and we're going to call that main. Now, you can leave this file empty for now. We're not going to touch any code for a few more minutes because we actually need to set up the project. The reason I want you to make a C++ file before you do anything else is because that lets Visual Studio know that we are making a C++ project. So now you're going to come over here and you're going to right click on Sexy ESP or whatever you named your project, and you're going to come over here to properties. Now, this is very, very important. This overlay can work for 32-bit or 64-bit games. It'll work for anything. But because in this video, we are targeting CSGO specifically, I am going to be using Win32. This is very important. But if you want to hack a game like Apex or something like that, you're going to be using x64. So please be very mindful of that. Instead of wherever I use Win32 or x86, you need to use x64. But yeah, so I'm going to use Win32 because we are making a CSGO tutorial today. And very importantly, you're going to want all configurations selected here. That means that any changes that we make right now are going to be applied to both release and debug. So first of all, in general, we're going to change our solution output directory. We're going to change it to a directory called build. And I'm going to copy this, and the intermediate directory, it's going to be the same thing except build intermediates. Now, the reason I do this is because otherwise, every time you compile, depending on your project configuration, it goes to a different place every time, and it's just annoying, and it's just not structured very nicely. Now, make sure your configuration type is an executable. We're not trying to make any libraries. We are very specifically trying to make an executable, and we're going to change our C++ language standard to C++ 20 and go ahead and apply. Now, the next thing we're going to do is we're going to click OK because we need to come back to our Solution Explorer, and we're going to make a new folder and we're going to call that external. Now, what this folder is going to contain is our external dependencies. So we are going to be using ImGui in this video, and ImGui is going to go into this folder. So we're going to create an ImGui folder inside of here, and we'll go get ImGui in just a moment. But you can just leave it like this for now. Coming back to our project's properties, we need to come over here to VC++ directories and include directories. We're going to add an extra one. So you go ahead and click edit, you click new line, and then you click these three dots, and we're going to add this external folder. Select folder. This essentially means that basically we're going to want Visual Studio to look in this folder every time we build, because it's going to contain files that we want to build with, and in this case it's going to be the ImGui project. We'll come back and we'll fill that out later. The next thing we need to do is come over here to linker and input. Now, ImGui it needs some sort of backend, and in this video, we're going to be using DirectX 11 to render ImGui. Now you can use whatever the hell you want because you're not bound to a specific game. For example, if we were making an internal CSGO cheat and you wanted to render internally, you would have to use DirectX 9 because that's what the game uses. Remember, we're external, we can use whatever we want. So I just think DirectX 11 is probably the safest option. But anyway, so you're going to come over here to input, and because we're going to be using DirectX 11, you need to add an additional dependency, and that's going to be d3d11.lib. We're going to need to actually link this d3d11 library to our program in order to compile the DirectX 11 functions. Anyway, you can go ahead and click OK. And the absolute last thing you need to do, I promise you, is you're coming to System and you're going to change from Subsystem Console to Subsystem Windows. And what this does is it basically says we want to make a traditional Windows application. And our application is going to start at the Windows entry point. It's not going to start at int main. It's going to start at int win main. And I'll show you what I mean in just a moment. So go ahead and click apply and OK. Now, remember, I have just set up my project for 32-bit application for CSGO. So at the top here, compiling in 64-bit is not going to help. I need to switch to x86. Once again, if you are making a cheat for something that is 64-bit, you are not going to do that. You are going to set up a 64-bit configuration and you're going to use it. Now, what we're going to do quickly is we're just going to make our entry point. So that's going to be include, and we're going to include windows.h, which is the Windows API. And we create an int API entry. And this function is called winMain. Of course, as you can see, it returns an int, so we can just make it return 0. Now, this function takes 4 parameters. First one is an H instance, and that's the instance of the current application. The next one is an instance, but it's not an instance to the current application. It's instance to the previous one, and we're not interested in that. So I'm not even going to name the parameter. We're just going to skip it. Then the next one is a pster. I said that very funny. Pstring. String pointer, and that's going to be the actual command line arguments that are passed through. We're not interested in those either. Now the last one is an int, and that int is called cmd show. And this int basically determines whether or not we want to show our window. And we're going to use this later on in the video. Now, the reason I've just made this entry point is so that we can test whether or not our project works. So we're going to go ahead and build this. I built in debug x86, and as we can see, build 1 succeeded. Over here, I have the project open up inside of my file system, inside File Explorer. And if I come over here to the build directory, as we can see, we have our sexy_esp.exe. And I can run it. It's not going to do anything because our program doesn't do anything yet. And intermediates contains all the objects, all the, databases and all that shit. No one cares about that. Okay, so here I am on the ImGui GitHub page. Once again, we are going to be using ImGui because ImGui has it's just a good framework in general, but it also has a really efficient 2D batch renderer, which we're going to actually use to render our ESP on our overlay. So to install ImGui, very, very simple stuff. You come over here, you hit the code button and download a zip. All right, so here I have the downloaded ImGui master. It's 1 for me because I downloaded it a couple days ago. But once you open up and you extract ImGui master, you have all of these files over here. And over here on the right, I have my project. We're going to be putting the ImGui code into our external folder over here. So external ImGui. And what we need from ImGui is from imstb truetype. We need all the way to imconfig. So I'm holding down shift, select all of those. We can just copy them into there. And then you need to come into backends, and we're on Win32. So scroll all the way to the bottom and grab the Win32. And we're going to be using DirectX 11. So find the ImGui impl DirectX 11 and drag that into your project as well. The last thing that's left is for you to return back to Visual Studio. You're going to come over here and you're going to click this refresh button. And once you click that, you should see that in your ImGui folder, you now have all of the ImGui files. We still do have a problem though. They have this little red icon next to them. And that means that the files have not been included in our project yet. Oh, 1 second, I see I've made a mistake here. I accidentally dragged in ImGui DirectX 12. Yeah, so as you can see, I dragged in ImGui impl DirectX 11, but I dragged in the wrong source file. So yeah, once again, make sure that you do this stuff correctly, or else you're gonna have serious problems. So I'm back in my ImGui extract thingy over here, and let's find the correct one this time, ImGui impl DirectX 11, and drag that in. So yeah, coming back to our solution, we now refresh this. And what you need to do is right click on the ImGui folder and say include in project. Now, if you remember earlier, we set up an external include directory or an additional include directory to this ImGui folder. So if I come over here to main.cpp, I should now be able to do something like include, if I could spell it correctly, include and then ImGui. As you can see, it's a folder, and then we can include imgui.h and so on and so forth throughout our project anywhere. So throughout doing this, please just keep in mind, keep building your solution, keep building a project, keep making sure it runs, it works, there's no problems. You don't want to sit here and code the whole project and then at the end try build and it fails and then your heart's broken. Like, that's the worst. You don't want to do that. So yeah, that basically wraps up setting up our project. So next we're going to go ahead and create a window and initialize DirectX and all that fun stuff and get ImGui running. So yeah, I'll catch you guys there. Alright, ladies and gentlemen, now that you've got your project set up and you are ready to get going, we're going to get started with creating our window procedure. This is essentially what a window procedure looks like. It takes these 4 parameters, blah, blah, blah. If you've never used the Windows API and made a normal Windows before, whenever you create a window, you need to supply a window with a window procedure. And what the window procedure does is it receives the messages that are being sent to the window. And through this function, we can actually filter and choose to act on messages that the window receives. Now, one of the most important functions of this in our program is going to be basically handing over the messages to ImGui. Now, in order to do that, we actually need to include the 3 ImGui files that we're going to be using in this project. So let's go ahead and do that. Once you've included imgui.h, imgui DirectX 11, and imgui Win32, you're going to right click on the Win32 one. You're going to click go to document. And if you scroll down a little bit, you'll find here Win32 message handler your application needs to call. So what you're going to do is you're going to copy this whole line, this extern imgui blah, 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 blah. You're going to copy it and you're going to come back to your main file. You're going to paste this in. And what this does is it basically says C++, or it says Visual Studio, listen, somewhere in this project, there is a function that's been defined that's called ImGui impl132 blah, blah, blah. And we're basically saying we want to be able to use it in our main.cpp file. So yeah, it's very important. You need to paste this extern declaration over here. Now, in order to pass the messages through to ImGui, it's as simple as if, then we call the ImGui impl whatever function, and then we pass through the parameters. So window, message, wparam and lparam. And if this function returns true, then what we're going to do is we're just going to go ahead and exit out of this function. We're going to return 0 from our window procedure. Now at the end of our window procedure, we're going to return def window proc. And def window proc is special because def means default. For all the messages that we aren't going to be handling, it's just going to hand it over to the default window procedure to handle the messages for us. So we don't have to type as much code. So we need to pass in the parameters through here: window, message, wparam, and lparam. And now the only message we actually care about is the wm destroy message. So we're going to say if message equals wm destroy, we're going to post quit message with code 0, and then we're just going to return 0l from this function. Cool, and that wraps up our window procedure. That's all we need from it, and we can now actually move on to creating our proper window. Alright, so the first step to creating a window on Windows is to first create a window class. So let's do that. We create an object of window class exw and we initialize it to 0. Now we need to set wc.cbsize. We set that to the size of window class exw. Next, we want to set the window class style, and we're going to set that to horizontal redraw and vertical redraw. Next, we're going to set the window process. So that is l something windproc is equal to window procedure. I keep saying process, I mean procedure. Now, next we're going to set the instance to our Windows main instance that's passed through. And last but not least, in our window class, we're going to go ahead and set the lpsz class name. And that has to be prefixed with an L because we are using wide strings here. So we're going to call this external overlay class. Doesn't really matter what you call it. We're just going to go with external overlay class. Now, once you have created your window class, the next step is to register it. So we call register class. Now, very important, we created a window class exw. So we need to call register class exw, and we pass in the address of our window class, just like that. All right, so now that we have registered our window class, the next step is to use that window class to actually create a window. Alright, so our call to create window, very importantly, once again, we're using create window exw. Now, the reason we use create window ex is because the first parameter of create window ex is this. It's these extended styles, and that lets us make this window topmost, transparent, and layered. Now, this here is the name of our window, so you can make that whatever you want, whatever your page sheet is called. And then here is your screen size. Now, this is very important. I'm hard coding it in just for the sake of simplicity, but you can use a function like get system metrics and then just get the screen size. That'll make your life a whole lot easier. But this is important because we are making our overlay the size of our main monitor so that it will sit over our entire main monitor. Cool. So now we can move on. The next thing we're going to do is we're going to call set layered window attributes. This first parameter takes a handle to a window, and of course that's going to be the window that we just created. Now the next parameter is some color reference key thing. We're not very interested in that, so we're just going to go RGB 000. It doesn't really matter what color you put in there, and I'll tell you why in just a moment. But this does matter. This is an alpha value, which we're going to set to 255. And then LWA alpha. So the reason that whatever color you pass in here doesn't matter is because what we've done is we're using the LWA alpha, the long window attribute alpha flag. And if we set this byte to 255 and we use this LW alpha flag, we're basically telling Windows that we do want to be able to see the contents of this window. If you don't do this, nothing will render. Alright, so the next thing we need to do is we actually need to extend the rendering frame of our window to the entire size of our monitor so that we can actually render over our entire monitor. Now, the code that you're about to see, a little bit difficult to explain. I just want you to copy it down for now. But before we do that, you do need to come to the top and we need to include a new header file called DWM API. Now, DWM stands for Desktop Window Manager. And that is the part of the operating system which controls all of your windows on your desktop. I mean, it's not exactly groundbreaking. So yeah, just follow along. Alright, so in order to call DWM or Desktop Window Manager extend frame into client area, we need the window handle, which we have of course, but we also need a essentially a structure of margins. Now margins, if we take a look here, it's literally just 4 ints and it's just left, right, top and bottom, regular margins that you would think. And of course over here we are calculating the margins that we want and we are using the window and client area. So yeah, it's not rocket science, but yeah, so we do need this or else shit will not render. Alright, ladies and gentlemen, we're now at a point where we are ready to start initializing our DirectX contexts. So before we do anything, we need to come to the top once more and we need to include the DirectX header file. So that's going to be d3d11.h. Now, the first thing we need to do is we need to create a DXGI swap chain description, and we're going to call that SD. And of course, we're going to initialize that to 0. Alright, so I don't think I have enough time in the world to explain every single thing that we've done here with the swap chain description, but what is important is that we are setting window to true and we are setting our output window to that of the window that we just created. And also here we are setting our back buffer's refresh rate, which we are setting to 60. Next, what I've done here is I've created a compile time array containing the DirectX feature levels that we desire. Now I'm going to initialize all of the DirectX variables that we are interested in. So follow along. Alright, so here are all of our DirectX variables, and now we can actually use the DirectX 11 create device and swap chain function to create all of them. So yeah, I'll see you in a second. Alright, so now that we have our device and everything created, the next step is for us to actually create our render target. So we can do that just like so. So over here, we create a back buffer, we then get the buffer using the swap chain, and then we can create our render target view like so. I've just put this inside of this weird looking if statement just because I was getting an error. It was saying the back buffer could be 0, so it's good to check that it's not a null pointer. By the way, on that note, I have not included a lot of error checking. If you take a look, all of these functions do return, as you can see, bool, bool, bool. You know, so you should be doing some error checking. But anyway, once we have our render target, all that is left to do is to show the window and update the window. And then we can move on to creating our ImGui context. These two functions are pretty self-explanatory, I'd say. They do exactly as you'd expect. But now it's time to move on to creating our ImGui context. So we start by saying ImGui create context. Then we're going to say ImGui style colors dark, just to set a theme. And then we can finally say ImGui underscore impl DirectX 11 init, and we're going to init with device and device context. And then we can initialize our ImGui context just by using the impl init functions, just like that. All right, ladies and gentlemen, it is finally time to move on to our main application loop. So we're going to create a little state variable. We're going to call bool running. And of course, that's going to be equal to true. And then we're going to say while running. The first thing we're going to do inside of this running loop is we are, of course, going to send the messages to our window procedure. So that is actually, we have to do that. That's not really a choice. So how we do that is we say MSG, we create a little message struct, and then we create another loop inside of our while loop. Okay, so let me see if I can try and explain this. We have this outer while loop that is going to run as long as running is true, and of course running is true. Now this inner loop over here, what it does is it sends the messages to our window procedure to be basically handled, or you know, whatever the window procedure does with the messages. But what's important here is that we're checking if the message is equal to a quit message, because if it is, we need to set our state of running to false. And then over here, if running is false, we're then going to break out, and that's going to close our application. So with that being said, let's go ahead and add some cleanup over here, because remember, if the program ever gets to this point, it's because we are closing the program. We've either clicked the close button, or it's crashed, or something's gone wrong. The first thing we need to do on cleanup is we need to destroy ImGui, or deinitialize it, whatever you want to call it. So destroying the ImGui context or the state is as simple as these 3 lines. Now, the next thing we need to do is we basically need to check the validity of these pointers, and if they are valid, we need to release them. So let's go ahead and do that. So these variables can be released just like that. Now we need to destroy our window, which is as simple as a call to destroy window. And then basically the last thing we need to do is to unregister the class that we registered earlier. unregister class W. Remember, because we made a W window class, or a window class W. And here we're just going to pass in WC class name, and then of course probably WC.instance. And that should handle closing our program. Now at this point, what we've done is we have all the initialization, we have the main loop, and we have all the shutdown set up. We just don't actually have anything in our loop. So this is where the rest of our code is going to go, right here in this spot. The first thing we need to do is actually start the ImGui frame, because every iteration of this outside loop is actually going to be a frame of our program. In order to do that, we do the following. We call the DirectX 11 new frame, we call the 132 new frame, then we actually call the ImGui libraries new frame. Over here is where you're going to render all of your fun stuff. And after you are done rendering, you're going to call ImGui render. Then what we need to do is set the color of the render targets. Once we have set the render targets color and everything, now we actually need to call render draw data from ImGui. So that's going to be ImGui underscore. It's going to be this impl 11 thingy going on here, and we're going to pass in ImGui get draw data. And last but not least, all that we need to do is call swap chain and present, and we're going to pass in 1u and 0u. This means that we are going to be actually rendering with vsync, which I suggest. It's much more performant. Now, before we do anything, let's go ahead and add something here to render. So I'm going to say ImGui get background draw list. Let's add a filled circle. Sorry. Now the center, we're going to put it 500, 500. The radius, let's make that 10.f. And then the color, we can make ImColor, and let's make the color red. 1.f, 0.f, 0.f. Just like that. So theoretically speaking, if we build this and run this, we should see a red circle on our screen. And if we take a look right there, we do in fact have a red circle on our screen. As you can see, it's still here, even if I go to my desktop. Here I have my Visual Studio open, and as you can see, it is rendering. In order to close this, we can just hover over the window and close it, and it works. Now, in order to turn this into a cheat, what you would do is you would literally just stick all of your cheat logic right inside of here, and then you render whatever. So let's say you have a kernel driver. What you're going to do is you're just going to run your cheat like normal in here. You're going to talk to your driver, you're going to render all of the data that you want. So when I initially planned out this video, I did plan on actually showing you guys or programming the ESP with you guys. But the video is almost 30 minutes long and I don't think it's necessary. I've shown you how to make the overlay and I've shown you how you can render on the overlay. So the version of this project that I'm going to post on Patreon will include the CSGO ESP. And hopefully, just to make it up to you guys a little bit, I am going to talk through how the ESP works, and I've got it open right over here. So essentially, this project is the same as the one we just coded. It does exactly the same thing. It just has ESP inside of it. This is the project that I demoed in the beginning of this video. All that's different about it is that we have this memory class over here, or sorry, this memory header file, which has your basic external memory manipulation things. We've got get process ID, get module address, and then a read and a write process memory wrapper. I've made like 50 goddamn videos about external cheats. All of this I've gone over like video after video. So if you're interested in this stuff, literally go watch any one of my other videos. Now, when it comes to actually creating the ESP, once you have made your whole project, you are going to need a few things. So first of all, offsets. These were the offsets I used to make the ESP, local player entity list view matrix. We need the bone matrix to get the player's head position. We need the team numbers so that we can compare team numbers to see who's on our team and not. Life state to make sure people are alive. Origin to get the position of their feet so that we can create the box. And then of course dormancy, which is very important. you will need a vector, a 3D vector class, and a view matrix class. And here's a world to screen function if you would like that. As for the actual ESP logic, it's very, very simple. Down over here, first of all, what we do is we try and get our local player. And basically, the cheat will only run if local player is valid. So if local player is valid, we then get our local player team, we get our view matrix. The reason I decided to get the team here is because otherwise I get the team inside of the loop. But remember, this loop is happening, 32 times. So that would mean I'm getting my team number 32 times, which is why I put it out here. It's just a small optimization. Then over here, we're reading the life state. If life state is not equal to 0, so if it is equal to 0, they're alive. If it's not equal to 0, they're not alive. We continue. Then we get the bone matrix. We get the head position. We get the feet position just by origin. And then all we need to do is world to screen both of those positions. Here, what I've done is I've added a little offset so that essentially the boxes look a bit better. If you want to know about the logic, I have a video about internal surface ESP, which uses literally, I use the same logic pretty much to make the boxes. And yeah, if you happen to have a kernel driver, well, what would you do? Well, you would just replace these memory reads. Obviously, instead of literally using read process memory, you would then, send a message to your driver, and then your driver would read the memory and send it back. And you do exactly the same thing essentially. So yeah, I really hope you did enjoy the video. It's taken me fucking hours to make. Drop a like, comment, subscribe if you want to see more content, if you enjoyed it. And, the source code will be on Patreon. And feel free to join my Discord server. And until next time, I'll see you guys. Cheers and peace out.